Hello, this is Professor Kim Nelson with the Jewelry Design Department at FIT. Tutorial for our drafting module in JD139, drafting pliers. I have here the imported and placed scan of my parallel pliers, and I've done some initial blocking in. Very little actually, just to center it up. Going to now begin to draft the top view. I'm going to be using my calipers. That's going to make for a challenging video because you can't see me using my pliers, but I'm checking all the dimensions. The offset I have there between the jaws, those first two construction lines, should be at 10.88 millimeters. So I will come to my curve tools, circle center radius, and do a diameter 10.88. And then I will look and see how that compares with what I have. And you can see that it was a little narrow on the scan. So I will update that now. Through point both sides intersect. Okay. I want to know how thick these blades are at the tip. They're 2 millimeters. So I'll offset 2 millimeters each side. I want to know what the distance is from the top of those pliers down to the corner here. That is a difficult dimension to pull using the caliper, but I can do a reasonable job. Roughly 25 millimeters. So I'll offset this 25 and compare it to my scan. Okay. I know my scan is rocked upward. That's why I can see the bottoms of those, so I'll accept that dimension. I need to know the width of my opened pliers. .36¼ So, circle center radius. I lost my center line. So, I'd forgotten my measurement. I'm sorry, 36¼ So, circle center radius, 36.25 is the overall width of my pliers. Offset this curve, both sides, through point, pick up that intersection, delete my reference circle. Draw a diagonal between this intersection and that. And I can now fill it. To get and trim, to clean up my drawing, and to get some elements that I can now consider part of my final piece. I'm going to go ahead and join, and put those on the white layer as drawing curves. So there, I've started this portion. Now I need to draw this handle portion. I'm going to freehand that. it has an intersection, a corner there. Going to measure a diameter or a thickness here of my handle. And it's kind of a variable thickness. But it's 9.5 millimeters. So I'll record history and offset that 9.5. Going to come and get the other side of the plier. Handle. There is another corner right here. And that corner is actually aligned with this rolling under of the handle. And that is a curvilinear thing. It's going to be very hard to plot or to capture. So I'm going to hold off on that for a minute. Go ahead and adjust these curves, because they were just sketched in. Finding a white line hard to see, so even though that's going to be the finished color of my piece, I'm going to put it in a color that's a little easier for me to spot. These are particularly important. I want to get the flow between these 2 points as close as I can to what I see here at the end. Turn on my curvature graph, double check. Okay, rebuild that curve before I play with it any further. It's at 10.3 now. I like 4th degree curvature, and I think it warrants about 15 points. I actually should have rebuilt it before I adjusted it, but not a big deal. And that's good. Same thing over here. Go ahead and rebuild it first. I don't think I need 15 on this side. I think I can buy 9. Turn on the points. And once again, I can see this opening in here, which is because my handle's tilted in the scan. I think that's reasonably accurate. Curvature graph looks fine. Not going to mess with that. So what I need to resolve now is how these two come in together. It's hard because the scan is gray on gray, but there is the edge of the handle right here. So I will begin with a fillet. And then I will come in and adjust the points on this. Rebuild my curve. Oh, 9 points should be fine again. Oh, I do want to put this on the red layer so I can see it well. And you'll notice the offset curve is updating automatically because I use history. So anything I do here gets updated over there. Alright. Okay. Now I'm going to analyze my handle here in my hand. There is a slight tapering that takes place up here. I'm going to measure and see what that looks like. actually that seems to be an optical illusion. I'm getting the same measurement. In fact, I'm getting 10 millimeters. Let's see. And I had originally pulled 9.5, so interesting. Yes, it is actually thicker. Yeah, it's about 9.75. So actually, I'm thinking, I thought it was thinner, and it actually widens a little bit here, which is surprising to me. Rebuild this curve. This will break history, which is okay. I counted on that. Going to adjust these points until my original offset curve flares thicker here in an appropriate way. Now what's happening here, I have a corner, and that corner is because there's actually a notch here in the pliers where the form changes from a flat surface to a rounded surface. So there's kind of a pinch that takes place. And in the front view, or top view I should say, that looks like a simple arc. It looks like that. Okay. So I'm going to, in fact, what it does is it comes down and it flows off of the bottom curve. So there's actually a smoothness that happens here. I'm going to create that smoothness by doing a circle center radius, trimming off both of these, and doing an adjustable blend curve between the two. I don't like how that worked, so going to do a regular blend curve, quick blend curve, and I'm going to do a command called end bulge. It's a keyboard entry command. It'll give me those handles, but these handles function slightly different than the handles on adjustable blend curve. They're a little softer. Okay. I like that better. And then this actually falls away, and this becomes the actual curve of the plier handle. So from the front view, this undersurface is not visible at all. That is the shape of the handle. Here at the top, I'm going to do a blend curve, adjustable. And I'm going to play with the handles independently here to mimic the curvature along the top there. Going to join those together. Okay, I'll put that on the drawing layer now. Okay, the challenge I'm going to have now is how to make the bottom of this, and to make sure that these end up being the appropriate length. I did an overall measurement of my caliper, so I know that this is correct. So I am going to trust. It's just a very difficult dimension to pull, so I'm going to trust the scan. I'm going to do a line, near snap, come off of here. I'm going to do it both sides. The both sides option will allow me to match what I'm seeing as I hold the caliper, the parallel plier in my hands. I see something like that. And then coming from the end, I see something that curves up. Like that. I'm going to take out the middle, trim it, and do a blend curve in between. I'll do a quick curve blend, and then fill it, and fill it. Throw these little pieces of curve away, and join these together. And that gives me the whole side of this handle. The last thing I need to do is I need to draft the underside of these plates. I need to know, if I can get it, how thick that overall plate is. That's probably not going to be possible. No, I can't get my caliper in there. But I can get the dimension of each individual piece. I know that the small tongue that is sticking down there is 1.3, 1.4. So if I offset this curve, I'm going to explode, so I can offset. If I offset this curve to where it appears to have that edge, and then I offset 1.4, that is lining up well, and that's a straight line coming back. Now I can measure the gap. And actually that gap will determine also the placement of the rivet you see up above there. The challenge on these pieces is to how to get the measurements with the caliper and how to get them accurately. That gap is 3.4 millimeters. Okay. And then this thickness I will try and get, but that thickness should be, I'm looking inside of the caliper now. I thought it was simply an extension of the jaws above, but it may not be. It looks like 5.2 millimeters. It's very hard to get a good dimension off the live piece. Let's take a look. No, you see, this is depicting very much what I see under here. So this is not a contiguous line. I thought it was. So I'm going to do that by eye, because I'm going to trust the scan in this case more than I'm going to trust my calipers, because I really couldn't get in there very well. And I'm going to trust my eye for this angle as well. I will draw the angle away from the edge so I can see the whole length of it, and then I'll move the curve that I drew into position. And if I don't like it, I will rotate it a little bit. I will be doing the entire top view in this video. There. And I will fill it, the curves. Use a straight line for the bottom of this. Once again, I'll draw it away from where I want it and move it into position. It's easier for me to see what I'm doing that way. Take a look at my caliper and see if I see any of that flat, and I do. So I'll draw another straight line and move it into position by eye. It's right there. And I'll fill at that edge. And this edge. Okay. And that will give me some of these assemblies that I can now count on as I keep drawing. I need to put this rivet where it needs to go. So I'm going to draw it right where I see it. Now if you had the pliers in your hand, you would see that the post of this rivet is what this is sliding through. So this actually needs to be centered up on that. I'm going to mirror this over. I'm going to delete the original. And I'm going to mirror it back over with history. With that mirrored with history, I can move this side and update that side. That helps me because I can see what's happening over here as well and see how far off I am from what I'm seeing here. Okay, I'm going to call that a good compromise. So what you can see with my plier here is that that completely changes where that's supposed to be. That's okay. Remember, this is tilted slightly on my scan bed, so I can accept that difference. I'm going to, actually I'll do it here. It's a 6-sided nut, so I'm going to divide my curve in 6. Do a polyline. And then I'm going to offset that polyline until it looks like the size of that nut. Now actually, I have a better solution than that, of course. I have calipers. So, and actually what I have discovered looking at this with calipers is that that appears to actually not be, it's hard to tell on the actual piece. Actually what that is it's a domed rivet cap, and it's just been chewed, so there isn't actually an 8-sided piece there. It's a good thing I looked, and the diameter of that is 3.7 millimeters. So put a circle, center radius from the center of this diameter 3.7. That's the size of it right there. And there is it's conical, but it's a rounded cone, so it's going to be very hard to see. And I'm going to do this freehand, or by eye I should say. It's about like that. Going to get the diameter on this side. It varies depending on where I measure it, of course. It's 4 millimeters. Circle, center radius, center 4. Okay. That looks a lot smaller than what I have in my scan. So I'm going to do a compromise between the two because it was hard to get the calipers to get a consistent measurement. It's kind of been beaten and forged, so it's not really a true circle anymore. And I'll take that. Okay. I need to know the diameter of this hub. It's 7.29. And 7.15 on the other, so I'm going to call it 7.2. That looks good. And then I have this bolt at the top, which is 6.3. I'll draw a 6.3 millimeter circle and then move it into position. Going to draw that slot, driver slot, curved straight line both sides, and I can actually measure that thickness with a caliper, but there's no point. I'll just do it by eye. It is there. I will trim off the ends of this, throw away the center line, and change this to a drawing layer. I'm going to take this and I'm going to mirror it to the other side with history. Because once again, I have some distortion going on here. I want to make sure that it falls in the right place. I'm going to use the Shift key to move that straight over. Use the Shift key to move it straight down. It's nice to constrain it so that you have more control. I'm going to call that OK. This center bolt, I think I'm going to turn off my image for a minute. I think it sits too close to the bottom edge of this, so I'm going to move it straight up. Once again, holding Shift key so it remains centered. Like so. I'm going to group these together and take this piece. I can throw this away because I know it's in the right position now, and mirror it over. And I know on this side this is a larger circle. Put this on the drawing layer. And about the last thing I need to do here is to change this from a circle bolt, the head of a bolt, to the to a nut and shaft. So that's 7.86 millimeters. I'm going to call it 7.8 because I think that's going to be more accurate. Move it into position. Center, center. Okay. Something interesting has happened once I do that. This is actually kind of crowding, so I will fix that in a minute. First I will divide this by 6. Draw my polyline. Delete that circle. Delete those points. And I'm going to bring back my image so I can see how it compares to my scan. It's favorable. My scan has it rotated a little differently, and I'll go ahead and do that. Why not? It has it rotated with the point straight up. Okay, like that. I'll hide that pigment again. I'm going to check with my caliper and see what the diameter of the shaft of the bolt is. It's 4.4. I will draw a circle from the center of this circle at 4.4. And that is the shaft and bolt. So now I need to mirror this over, because as I said, I don't care for, I'm going to mirror this small circle with history. I don't care for the placement. So I'm going to take this piece now and move it to where this seems like it's centered better. And then move this accordingly, center to center. And I think that is more successful. Okay, bring back my drawing. I need to mirror over these elements. Bring back my scan. And now trim in the appropriate places. And here, and here. Delete those portions. Going to do the same for this side. Delete any extra lines. Okay, that is principally the top view for this pair of pliers. The only thing I do want to put in here is I want to put in this fold line. And I'll do that by doing a line from the center here, both sides, till I get a good mimic of that angle, and I'll offset it. To catch it there. I'm going to trim these both off. Now, to show that this isn't a hard corner, that it's a rounded corner, I'm going to take the ends off of those lines. And the way I'm going to do that, I'm going to go to mid-snap, and I'll draw a circle that comes close to the end. And then I'll use the same circle, if possible, to trim off the ends of this one. Put those on the drawing layer. Okay, and that's it. That is a clean technical for this piece. Now, I have decided that I made that circle too small. A little bit longer, so they seem a little crisper. The closer they come to the edge, the crisper they look. And while it's rounded, it's not terribly rounded, so I believe that'll give me a better result. Yeah. So when I'm done, I have my top view and 2 center lines. Thanks for watching.